Hello everyone. Today we will apply the knowledge that we have learned during the study of graphical analysis of linear and non-linear equation using two variables. That is video number 9 of rectilinear motion. Now in our last video we have actually classified motion into two categories. That means we can represent motion into two categories. The first kind of motion is uniform motion. We know it because here V remain constant or uniform. Now this kind of equation, this kind of motion actually represented by the equation S is equal to Vt. That is actually the displacement in this kind of motion is represented by the equation S is equal to Vt, and we know that this is in the form of y is equal to mx. So this is an equation of straight line. So obviously if we plot a graph between S and T, then we will going to have a straight line, straight line actually. And the second kind of motion is a non-uniform motion. Now this non-uniform motion are two types. The first one is uniformly accelerated motion, where acceleration remain constant and v changes with time. And the second kind of motion is an non-uniformly accelerated motion. Now we are yet to see this kind of motion actually. So basically right now we will study about these two things. Now there are several equations for uniformly accelerated motion, but here we are talking about displacement and time relation. So we know that in a uniformly accelerated motion, the displacement time relationship can be represented by S is equal to ut plus minus half at square. We actually use both plus and minus sign, positive and negative sign, because there can be acceleration as well as retardation. So this S is equal to ut plus half at square, which actually represents the displacement time relation when a particle in an uniformly accelerated motion, is actually in the form of y is equal to ax square plus bx plus c. Now this is a non-linear equation and actually it is a parabolic equation. So if we plot a graph between S and T, we will get a parabolic kind of graph here. Now what we actually do during the during the study of motion is actually we are quantifying motion by this equation. So in uniform motion we use S is equal to Vt. In non-uniform motion we use S is equal to ut plus half at square, or V is equal to u plus at, or V square is equal to u square plus 2as. So we have generally these three equations, and we can modify this equation for particular cases actually. So what we do, we are actually expressing motion in terms of these parameters. That means x, v, a and t. That means displacement, velocity, acceleration and time. Now that is actually by x and t, because we know that this velocity and acceleration is a dependent variable, dependent physical quantity, which actually depend upon x and t. So we actually expressing motion in terms of x and t. Now what is the advantage of using this equation? What is the advantage? That means what is the advantage of expressing motion, quantifying motion in terms of x and t? Now the answer is quite obvious. We actually find the different states of motion by using this equation. That means if we know the value of certain physical parameters, say at any instant of time, then we can calculate, we can use this equation, we can calculate the other phases also, the other condition of motion also by using this equation. Such as, suppose a particle is traveling with an initial velocity u and acceleration a, and we want to find what is the displacement of the particle at certain instant of time. That means we know the value of t. So by using the equation S is equal to ut plus minus half at square, we actually calculate the displacement of the particle at different instant of time. So use different value of t and you will get a different value of displacement. That means at different interval of time you will going to get a different value of displacement. So we can use any of this equation for finding different parameters, different physical quantities during the analysis of motion. But this method of analysis obviously a numerical method and quite rigorous one, because for finding the value of u or v or acceleration, that is velocity or acceleration, for every value of t you have to solve the equation and you need to find the value of this physical parameters for different values of t actually. So this is a numerical method and it can create a really very big problem when the physical parameters like the velocity is not a stepwise changing, not changing in a stepwise manner actually. That is, it is changing in an ever-changing manner. Like in case of a freely falling body. In case of a freely falling body, you will find the change in velocity even at a very small interval of time, say at an interval of time of 0.001 second or 0.0001 second. That means the body, suppose the body is traveling at 1 second, the velocity of the body, in case of a freely falling body actually, the velocity of the body at 1 second say at v, and at 2 seconds the velocity of the body is say v prime. So it doesn't mean that in between 1 and 2 seconds the velocity, the object is actually traveling with this velocity, because in case of a freely falling body, the force of gravity is actually acting continuously on the body, and as a result there is a continuous change in the velocity. So you can have a change in velocity for even a very small interval of time, say 0.001 second or 0.0001 second, 0.0001 second or a smaller interval of time. So this makes our problem really very difficult, because there are infinite choices of time, and for each time interval you need to solve this equation and you have to find a different value of the displacement. Now here comes the advantage of using a graph, because in case of plotting graph, we actually plot a best fit curve. We have our data for plotting the graph actually at different instants. Suppose we are plotting S versus t graph in case of a freely falling body, then you will going to have a graph like this. A graph like this, obviously it is an uniformly accelerated motion. So during plotting of graph, we will represent time along x-axis, time in second, it is increasing along positive x-axis direction, and displacement, which is in meter, is increasing along the positive y-axis direction. So in case of a freely falling body, you will going to have a graph like this. Obviously it is an uniformly accelerated motion, so you will get a parabolic kind of graph. Now suppose this is the position of the object, this is the displacement of the object at time 1 second, and this is the position of the object at time 2 seconds, and this is the position of the object say at time 3 seconds. Now if someone asks what is the velocity of the object, say 2.5 seconds, so 2.5 seconds. So we can find the velocity of the object, we can find not velocity, the displacement actually. So we can find the displacement of the object in two ways. The first one, use the value of the time t is equal to 2.5 seconds and plug the value of t into this equation, and you can have a value of displacement. And the second one is, draw a perpendicular from 2.5 seconds into the graph. It will cut the graph at this point, say at point P, and draw another perpendicular from the point P to the y-axis. Now y-axis represents the displacement, so you are going to get the value of displacement at 2.5 seconds from the graph. Now this is quite easy. You do not need to solve any kind of equation, and just by drawing two perpendicular you can have the value of displacement. Now the second advantage of using the graph is quite obvious. By looking simply onto the graph, by taking a glance onto the graph, you can have the idea about the motion of the object. Like during the study of our motion, you will find that in case of an uniform motion, you are going to get a graph like this, a straight line kind of graph. Why it is straight line? Because uniform motion is equal to the governing equation of uniform motion is S is equal to Vt, which is in the equation of which follows the equation of y is equal to mx. And in case of uniformly accelerated motion, the graph looks like this. Now obviously along this axis there is time, and this axis say there is displacement. So this axis time and this axis displacement. So uniform acceleration, so in uniform motion you are going to get this kind of graph, and in uniformly accelerated motion you will going to get this kind of parabolic kind of graph. So this can be used as an identifier. You can identify the motion by these two graphs actually. Now onwards, when someone asks by showing this graph, if someone shows this graph to you and asks what kind of motion it is, then you can easily say this is a uniform kind of motion because it is a straight line. The displacement time relation is a straight line. And if someone asks you what is this kind of motion, then you can easily say that this is an uniformly accelerated motion because this is a parabolic kind of graph. So by just taking a glance into the graph, you can say what kind of motion it is. So graphs are actually very useful for comparing the data. Here we are actually comparing S versus 2, we are actually S versus T actually. We are actually seeing the change in S with respect to the T actually. And we can use this graph to identify the motion by just looking into this graph. So this is the advantage of using graph. Now in motion, we actually represent motion, we actually quantify motion by these four parameters x, v, a and t. So we will going to get graph of these quantities varying with t. The first one is displacement. So what kind of graph we will actually deal in future, we are just looking into that we can find change of x with respect to the t, that is position versus time graph, that is x versus t graph. Similarly, we can say it displacement versus time graph, or s versus t, or we can call it distance versus time graph, that is d versus, say d represents the distance covered, so d versus t. Now there is a little bit difference in all these three kinds of graph actually, and we need to understand all of this graph for our exam like NEET and joint. Who doesn't want to clear this exam actually? Now see, there is another kind of graph, that is velocity versus time graph. So we can just modify it in some sense, and we can say it to be speed versus time graph. Obviously there is a distance between velocity versus time and speed versus time graph. We know that distance between velocity and speed actually. So we have to deal with these two graphs also, and there is a change of acceleration with respect to the time. So we will plot acceleration versus time graph, that is a versus t. Now we will plot all this kind of graphs for these two kinds of motion. So we will start from the simplest kind of motion, that is an uniform motion. So uniform motion. So governing equation of this kind of motion is S is equal to Vt, where S is the displacement. Now say x is the displacement of the object at any time interval t, and x prime is the displacement of the object at any time t prime. Therefore, this equation S is equal to Vt can be represented by x prime minus x is equal to V into t prime minus t, or we can write V is equal to x prime minus x divided by t prime minus t, t prime minus t, or we can write x prime is equal to x plus v into t prime minus t. We can write it as delta t, or simply t, or simply we will write it to or say it is delta t. So we can use this equation for calculating different position of the object when it is in a uniform motion. Now suppose a real life example, suppose an object at time is suppose an object or a particle is negotiating in uniform motion, and at time t equal to 0, say the particle is 10 meter away from the origin. So its initial displacement from the origin is 10 meter, and suppose its velocity v is equal to 15 meter per second, which remain constant during its entire motion because it is an uniform motion. So by using this equation, we can actually find the displacement or the position of the particle at different instant of time. So first, before plotting x versus t, we need to tabulate the data by using this. We need to find the data and tabulate those data by using this equation actually. So suppose at t is equal to 0, 1, 2, 3, 4, 5-second time interval, we need to find what is the value of x. Now t is obviously in second and x is in meter. X is the position of the particle, say. Now if we can find that, we can see that when time is 0 second, the particle is 10 meter away from the origin. So we can write the value of position of the particle is 10 meter, and at 1 second we can easily use this equation to find the value of position of the particle at an interval of 1 second. That means initial velocity we can find x1. Suppose x1 is the velocity of the object at 1 second interval. So x1 is equal to initial velocity 10. That means the value of x is 10 plus value of velocity is 15 meter per second. So 15, and delta t, that means change in time. We are dealing with the change in velocity, change in position between 1 and 0 second. So we can write 1 minus 0 second, that is 1. So it will be 10 plus 15. So we will have a velocity, we will find the particle in a position of 20 meter away from the 25 meter away from the origin. So it is 25 meter. In the similar manner, if we find x2 will be 10 plus 15 into time interval is 2 seconds. So 2 minus 0. So this is 30 and this is 10. So you will have 40 meter per second. So this one will be 40, and 3 seconds. Similar in this similar manner, if we calculate, so 3 seconds it will be 55, because 3 5s are 315, 45, 3 into 15 is 45 plus 10, so it is 55. Now again 4 into 15 is 60, 60 plus 10 is 70, and similarly at 5-second interval its position is 85 meter away from the origin. Now by using this tabulated data, we can plot a graph between displacement or position versus time of a particle in uniform motion. Obviously time will be represented along x-axis. In second it is increasing in this direction, and this will be obviously position x, which is actually in meter per second and increasing along the y direction of the graph. Now if we plot the data, suppose this one is 1 second, this one is 2 second, this one is 3 second, this one is 4 second, and this one is 5 second. So each unit here we can find that in the graph, each unit along the x-axis, each division is taken as 1 second. Each bigger division is taken as 1 second. And suppose this one is your position and this one is say 10, 20, 30. In this manner it is increasing in this direction actually, 30, 40, 50, this is increasing along this direction. So we can find from the table that at 0 second the particle is situated 10 meter away from the origin. So we will find this point. At 1 second the particle is 25 meter away from the origin, so it is say at this point. At 2 seconds the particle is 40 meter away, so this will be here. At 3 seconds the particle is at 55, so at 3 seconds it will be here. So in this way we can plot all the points in the graph sheet, and if we best plot, if we connect the dot using the connect this point by a best plot curve, then you will find a straight line, this kind of graph actually. Now you can see that this is a straight line. Why it is a straight line? Because it is in the form of y is equal to mx. Here you can see that our equation is this one. Now if x is equal to initial position, if suppose here the particle is starting its journey from 10 meter away from the origin, but there can be a case actually where the particle starts its journey from the origin. So in that case this x will be 0, this initial x will be 0. So you can write x prime is equal to v into delta t. So x prime is equal to v into delta t. So this is in the form of this is in the form of y is equal to mx. Now as we know, in this equation y is equal to mx, m is nothing but y is equal to mx equation, this m is nothing but slope or inclination or tan theta, and we know that if theta is very small, then tan theta is nearly equal to theta, and this can be represented by y by x, that is change in y axis by change in x axis. So that is practically delta y by delta x. So change along y axis by change along x axis. Now what we have along y axis is the position of the particle. So we can write change in, or we can write along y axis there is change in position of the object divided by along x axis there is time, so change in time. Now we know this physical quantity that represents change in position by change in time, and that is obviously velocity. So velocity. So we get a very interesting point, a very important point from here, that the slope of position versus time graph. So make a note of this. So take a note of this, that slope or inclination of position versus time graph is velocity. So change in position. So what is change in position? Change in position is x prime. In generalized form it is x prime minus x divided by t prime minus t. So it represents the velocity, that is x prime by x prime minus x divided by t prime minus t. So this is our graph, and say at this point position is x, and at this point position is x prime, and say at this point time is t, and at this point, these are the perpendiculars actually, at this point time is t prime. So this time, this change in slope, that is we need the slope, that is inclination, this theta. So this tan theta, this is perpendicular and this is base. So tan theta, we know that tan theta is equal to perpendicular by base. Now in perpendicular we have change along y-axis divided by change along x-axis, that is change in position delta x divided by delta t. So tan theta, we are having delta x by delta t, so tan theta is equal to x prime minus x divided by t prime minus t. Now we can use this fact to verify that actually it is velocity or not. Now suppose from the graph we can find that suppose we know that the velocity is what? X prime minus x divided by t prime by t. Now suppose we know that what is the velocity of the object at 3 seconds? It is 55. What is the position of the object at 3 seconds? It is 55. And what is the position of the object at 2 seconds? It is 40. So we can find, to check the fact that whether it is actually representing the velocity or not. So if we check the data between 3 seconds and 2 seconds, then the position of the object at 3 seconds is x3 and position of the object at 2 seconds is x2 divided by t3 minus t2. So it will be x3, the value of x3 is 55 and the value of x2 is 40 divided by 3 seconds minus 2 seconds, so 3 by 2. So it is 15 meter per second. Similarly, you can check it in between 4 seconds and 3 seconds. So x4 will be 70 and x3 will be 55. So again 70 minus 55 it will be 15, and 15 4 minus 3 it will be 1. So it will again between x4 minus x3 divided by t4 minus t3, it will be 70 minus 55 divided by 4 minus 3. So again it is 15 meter per second. So we have checked the fact that in case of position time graph, the inclination or the tan theta or the slope is actually the velocity. And for this particular case it is a uniform motion, because we can see that here velocity remains constant. For each interval of time the velocity remains constant. Now we have to find now we need to plot actually the second kind of graph, that is the velocity time graph for this uniform motion. In order to do that, we need to extend our graph and find the values of velocities. So what is the velocity between 0 and 1 second? It is 25 minus 10 divided by 1 minus 0, so it is 15 meter per second. So velocity will be in meter per second. And at 2 seconds it will be 15, at 3, in between 3 and 2 seconds it is 15, in between 4 and 3rd second it is 15, in between 5 and 4 seconds it is again 15. So it is 15, 15, 15, always remains constant. That is why it is a uniform motion. This is why it is called an uniform motion. Now if we plot the velocity versus time graph, now we know that during the plotting this kind of graph of motion, we generally plot time along x-axis. Time is represented in second, and this time we will plot velocity, which is in meter per second and increasing along positive direction of y-axis. So velocity will be in meter per second. So if you plot this graph, then what we will find? See, at 1 second its velocity is, suppose this one is 10, suppose this one is say 20. So in between 10 and 20 there is 15. Okay, so at 1 second its velocity is 15, at 2 seconds again its velocity is 15, at 3 seconds again its velocity is 15. Okay, so if we connect this dot by best plot curve, then you will find a straight line. Again it is a straight line, and straight line is parallel to time axis. So here again we can make a note of this, that in case of uniform motion, the velocity time graph is a straight line parallel to time axis. Now we can find that there is no slope in this graph. The velocity, why there is no slope? Because velocity is not changing. So that is why there is no slope. So slope of the graph is 0. So we have two important points from this two graph. We can get two important points. Now if we find, now suppose we calculate the area of this velocity time graph. So in between 1 and 2 seconds, we are calculating area. So area is the area bonded between 1 and 2 seconds. Now this is obviously V and this is obviously delta T. So this area of velocity time graph. Now this time area of velocity time graph is y-axis, that means height, and breadth, that means V into delta T. Now what is V into delta T? Obviously it is the displacement covered by the object, that is S. So S is equal to V into delta T. So we can write another point that area of velocity time graph is the distance covered by the object. So from the position versus time graph, we can write that during uniform motion, the position versus time graph is position versus time graph or curve is a straight line inclined to time axis. So identify uniform motion by using all of these four properties. So wherever we get and a straight position versus time graph which is inclined to the time axis, we will say that this is a uniform motion where the velocity remains constant. So obviously the velocity time graph will also be a straight line and it is parallel to the time axis. If you find the area of the velocity time graph, then that area will be the distance covered by the object in that time interval, and also the velocity, also the inclination of the position time graph is nothing but the tan theta or velocity of the position versus velocity of the uniform motion actually. Now coming to the third kind of graph, that is acceleration versus time graph. Now we are not going to get any acceleration versus time graph for uniform motion, because what is acceleration? Acceleration is change in velocity, and you can find that there is no change in velocity. So uniform motion acceleration versus time graph, so this one is time in second and this one is acceleration in meter per second square, then this one is acceleration along y-axis and it is in meter per second square and increasing along the y-axis, then there will be no curve generated because there is no value of acceleration. So acceleration remains 0 because acceleration is change in velocity and there is no change in velocity with respect to the time. Now we are going to see all these three kinds of graph for uniformly accelerated motion, which is a special case of non-uniform motion. So uniformly accelerated motion. So first kind of graph is position time graph. So position time graph. So this time we are plotting position time graph, that means x versus t graph for an uniformly accelerated motion. Now suppose that a particle, now the governing equation for this uniformly accelerated motion, in order to find the position in different time, we have s is equal to ut plus minus half at square. Now suppose we are dealing with acceleration, then the equation will be s is equal to ut plus half a t square. Now obviously this s is nothing but the displacement. So displacement can be written as final position. So suppose the final position is x prime and the initial position, suppose that the initial position is x naught, then x minus x naught is equal to ut plus half at square. Here all of we know that u is the initial velocity and x naught is the initial position of the particle. Therefore the actual position of the particle after time t will be given by x naught plus ut plus half at square. Now if it is a retardation, then you can write the same equation, x naught plus ut minus half at square. Okay, now this is the equation we can find in order to, this is the equation we can use for finding the actual position of the particle. Now take a real time data. Suppose our particle is traveling with a velocity, say initial velocity u is equal to 5 meter per second. And now suppose the acceleration of the particle a is 5 meter per second square. And suppose the initial position of the particle, that means at time t is equal to 0, the particle is not starting from the origin, not starting its motion from the origin, but it is starting its motion from, say, x naught is equal to 10 meter away from the origin. Now we have to plot s versus t graph. So s versus, that means displacement, or specifically we can say x versus t graph, that means position versus time graph. So in order to plot this kind of graph, we need to tabulate the data. By using this equation, we can find the data. So at, this is t is denoted in second. So at 0 second, 1 second, 2 second, 3 second, 4 second and 5 second. Okay, now we need to find the position. So position will be given in meter. So we can see that when at time t equal to 0, that means at time t equal to 0, the particle the particle is situated at a distance 10 meter away from the origin. So we can write 10 here. Now we need to determine what is the position of the particle after 1 second. So we can write, suppose the position of the particle is x1, so we need to find x1 is equal to x0. Now x0 is equal to 10 plus ut. Now what is u is 5 meter per second. So we can write 5 into time interval is, that is change in time, so 1 minus 0 plus half a is 5 meter per second square, so 5 into time interval, that is 1 minus 0 seconds whole square. So you will get 10 plus 5 plus 2.5, so you will get 17.5 meter. So at 1 second the particle is situated at 17.5 meter away from the origin. In this way you can also calculate x2. So x2 will be 10 plus 5, because initial velocity is 5. Now this time you have to use 2 minus 0, because the time interval is from 0 to 2. So half into 5 into 2 minus 0 whole square. So you will get 10 plus 10 plus 10. So you will get 30 meters. So this time the particle is 30 meters away from the origin. In this way you can find, by using this equation you can find the position of the particle at 3 seconds will be 47.5, at 4 seconds it is 70 meters away from the origin, and at 5 seconds it is 97.5 meters away from the origin. So in this way, by using this equation you can calculate the position of the particle at different instant of time. Now you can plot s versus t graph. So we can, all of you know that during plotting the graph we need to plot time along x-axis. So suppose this is time is represented in second, so time is increasing along the positive x-axis, and along the positive y-axis this time we will represent position of the particle, that means x, that is in meter, and it is increasing in the positive y direction. So if you plot, suppose this is your first division, that is 1 second, this is 2 second, this is 3 second, this is 4 second. In this way you can plot the graph for any other interval of time. So at 0 second, this is the origin. So at 0 second the particle is 10 meters away from the origin. Now obviously we need to find the division along the x-axis also. So suppose this is 10 meter, this is 20, in this way this is 30, this is 40. So in this way time position is increasing along the y-axis. This is 50. So at 0 second the position of the particle is, at 0 second the position of the particle is 10 meter away from the origin, and at 1 second it is at 17.5 meter. So this point at 2 second it is at 30 meter, at 3 second it is at 47.5 meter. So this will be 47.5, and at 4 second this will be 70. So it will be a point out of our graph paper. So you will find a graph if you best plot the graph. If you connect all the dot by best fit curve, then you can find a graph like this. So obviously this is a parabolic graph. You can see that this is a parabolic graph. And why it is parabolic graph? Because the equation we are using for finding the coordinate, that is s is equal to ut plus half at square, it is actually, you can write in terms of position, you can write this is x prime is equal to x naught plus ut plus half at square. So it is actually in the form of y is equal to ax square plus bx plus c. You can see. So this is the equation of parabola. That is why you are getting a parabolic kind of graph. So as a property of uniformly accelerated motion, so property of uniformly accelerated motion, we can write as our first point, that is the position time graph is parabolic in shape, parabolic in nature actually. So wherever you get a graph, a parabolic graph, parabolic x versus t graph, you can say that the velocity, the motion of the body is an uniformly accelerated motion. Like for example, you will get the same kind of graph for a freely falling body. Now in order to plot the velocity time graph, we need to find the coordinates of velocity actually. Now in order to do that, we cannot use the equation v is equal to delta x divided by delta t. That means simply we cannot use this equation because obviously velocity is the rate of change of displacement, but if you write it as x prime minus x divided by t prime minus t, then this is an equation which characterized an uniform motion. So you are not going to use this equation. Actually, there is a specific equation by which you can find the velocity when a particle in an uniformly accelerated motion, and that equation is v is equal to u plus minus at. You have to use this plus minus sign accordingly to that depends actually on the acceleration, whether there is acceleration or retardation. Suppose in this case we are talking about acceleration, then you can use v is equal to u plus at. Now we will use this equation to find the coordinates of velocity. You can see that the velocity of the particle at 0 second will be, suppose this is v naught. So v naught will be u plus a into, this time t is 0, so obviously you will get u. Now u is 5 meter per second, so you can write this is 5 meter per second. Now velocity, we are finding velocity at different instant of time. Now that will be in meter per second. So at 0 second its velocity is say 5 meter per second. Obviously you can see it from the given data. Now at 1 second we need to find the velocity. So v1 is equal to u. Now what is u? U is 5 meter per second plus what is acceleration? Acceleration is again 5, and this time interval is 1 minus 0. Actually the equation, in this equation we are using t. Actually this t is not t, that t is denoting delta t actually, that means change in time. So v1 is equal to 5 plus 5, so you will get a velocity of 10 meter. At 1 second the velocity is 10 meter, and at 2 seconds, velocity is denoted by say v2. v2 will be 5 initial velocity because the equation is u plus at. So initial velocity is 5 plus a is acceleration 5 into this time we will use 2 minus 0 because the time interval is this time is 2 seconds. So 5 plus 10 you will have 15 meter per second. So this is 15 meter per second. In this way, if you calculate, you can find the velocity at 3 seconds will be 20 meter per second. At 4 seconds it will be 25. At 5 second it will be 30 meter per second, and so on. So you can see that the velocity is changing at a rate of 5 meter per second. Obviously, you can also see it from the given data because the acceleration is 5 meter per second. Now what is acceleration? Acceleration is the rate of change of velocity. That means at every second the velocity of the particle is increasing at a rate of 5 meter per second. So this is our equation and this is our velocity. So now you can plot velocity versus time graph. So obviously we will plot our time along time t in second along positive x-axis and velocity in meter per second along positive y-axis. So this time you can see that at 0 second the velocity of the particle is 5. So suppose this is 1 second, this is 2, this is 3, this is 4 and this is 5 and so on. And at say this is 10, this is 5 meter per second, this is 10 meter per second, this is 15 meter per second, this is 20 meter per second, this is 25 meter per second, this is 30 meter per second, this is 35 meter per second. So in this way velocity is increasing along the positive y direction. So you can find that at 0 second its velocity is 5 meter per second. So we are starting our graph from this point. At 1 second its velocity is at 1 second its velocity is 10 meter per second. So this point. At 2 seconds its velocity is 15 meter per second. At 3 seconds its velocity is 20 meter per second. At 4 seconds its velocity is 25. At 5 seconds its velocity is 30. So if you connect all the dots, then you will get a straight line. Now why it is a straight line? Because v is equal to u plus at is actually in the form of y is equal to mx plus c. So now you can write as the second property of uniformly accelerated motion is the second point will be the velocity time graph in uniformly accelerated motion will be a straight line tangent inclined to time axis, that means the x-axis. So what we will get if we find the slope of this velocity time graph. Now suppose the position of the suppose at any instant of time, suppose at t time, this is the velocity of the particle. Suppose this is v, and suppose at t dash time or t prime time the velocity of the particle is v prime. Okay, so if we find the slope of this graph, then what we have to do? We need to find the base, the change. This is base and this perpendicular. This is base and this is perpendicular. So this is perpendicular. Okay, so this is perpendicular. Now you can see that perpendicular is nothing but the change along y-axis and base is nothing but the change along x-axis. So if you find this slope theta, then you can say that slope or inclination is equal to tan theta. So tan theta is equal to p by b, this time delta y by delta x, and this time along y-axis there is change in velocity. So change in velocity divided by along x-axis there is change in time. So we know the quantity that denotes the change in velocity with respect to the time. That is nothing but acceleration. So acceleration is change in velocity, that means final velocity v prime minus initial velocity v divided by t prime, change in time, that is t prime divided by t. That's why we are getting the equation v prime e minus v is equal to a into t prime minus t. So this v is the initial velocity, which generally denotes the final velocity by v, and initial velocity we denotes it by u, and a and t denotes the change in time actually. So v minus u is equal to at. That is our equation. So this is acceleration. Now we can say that the slope, this can be used as another property of uniformly accelerated motion, and that is the slope of velocity time graph is acceleration. So as a third point we can write slope of velocity time graph is acceleration. Now we can cross check our data by using, because we have real time data, so we can cross check this fact that whether acceleration is change in velocity or not. So suppose we are dealing with change in velocity, say at 2 and 3 seconds. So 2 and 3 seconds. So at 2 seconds we can see that velocity is 15 and at 3 seconds velocity is 20. So velocity at 3 seconds minus velocity at 2 seconds divided by 3 seconds minus 2 seconds, obviously it will be 1. So velocity at 3 seconds is 20 and velocity at 2 seconds is 15. So 20 minus 15 divided by 1. So you will get to 5 meter. Now see, here in this way you can find the unit of acceleration actually. This is change in velocity. So obviously this 20 minus 15, unit of this thing is meter per second, and below you will get 3 minus 2, that is time, change in time. So this will be 1 second. So 5 meter per second divided by second. So in this way you will get 5 meter per second square. Now you can see that this is our acceleration, that is 5 meter per second square. This is the acceleration with which we are started. So in this way you can find the difference between the velocity between 4 and 5 seconds. So you will get 25 minus 20 divided by 4 minus 3. So again it will be 5 meter per second square. Now why we are getting, you can see that we are getting a constant acceleration every time. So that is why it is known as an uniformly accelerated motion, because here the acceleration remain constant. That means the rate of change of velocity with respect to time, that means per unit time the change in velocity will remain constant. That is why it is known to be an uniformly accelerated motion. Now we can find acceleration by using this equation actually. So acceleration is what? Change in velocity. So change in velocity. So you can see that change in velocity between 1 and 0 seconds. So acceleration, it is denoted in meter per second square. So change in velocity between 1 and 0 second is 5 meter per second square. 5 meter per second square. At 2 and 1 it is again 5 meter per second square. Between 3 and 2 it is again 5 meter per second square. In this way you can find by this equation the acceleration will always remain constant for this particular case of motion. So you can have acceleration at constant. So this time if we plot acceleration versus time graph, so just if we plot acceleration versus time graph, so time along x-axis, time in second, so time along x-axis, so time in second, and acceleration is along y-axis, it is in meter per second square and increasing along positive y direction. So you can see that it is always remain at 5 meter per second square. So this point is 1, this point is 2 seconds, this point is 3 seconds, this point is 4 seconds, and suppose this is your 5 meter per second square, this is your 10 meter per second square. So in this way acceleration is increasing. However, we do not need this other division actually, because acceleration remains constant at 5 meter per second square. So at 1 second, at 0 second its acceleration is, at 1 second its acceleration is this one, At 2 seconds its acceleration is again 5, at 3 seconds its acceleration is 5, at 4 seconds its acceleration is again 5. In this way, so if we if we connect the dot using the base plot graph, then you can find this is a straight line parallel to the time axis. So this property we can use as an identifier of uniformly accelerated motion. So for uniformly accelerated motion, we have our point number 4, that is acceleration versus time graph is a straight line parallel to time axis. Now what will happen if we find the areas of this graph? Now you can see that in case of uniform motion, when we are calculating the area of velocity time graph, we actually have the distance covered by the time. Now this time we are again going to check whether the area of the velocity time in this case of uniformly accelerated motion also implies certain meaningful or not, certain meaningful thing or not. So we have seen that the velocity time graph was a straight line starting from 5 meters per second. So because the initial velocity of the object is 5 meters per second. And at 2 seconds, suppose at 2 seconds its velocity was 15. So at 2 seconds, suppose at 2 seconds its velocity was how much? 15. And say at 1 second its velocity was 10. So this is 10. Now we need to find the area of this curve, that is the curve in between 1 and 2. So area of this entire curve that lies between 1 and 2. Now you can see that this is a trapezium kind of thing, and you can find the area by the simple formula of by using the formula of area of trapezium. However, we can divide this area into one rectangle and one triangle. Now this rectangle, this height of rectangle is how much? 10, because we know that velocity at 2 seconds is 10. So this is 10, and this difference is in between 1 and 2, so this is 1. So area of this rectangle, and if we add the area of this rectangle and area of this triangle, then you can have the area of the whole area. So area of this rectangle is 10 into height into breadth, that is 10 into 1, plus area of this triangle is half into base is 1 into height. Now what is height? Height is 15 meter, 15 minus 10. So height is 15 minus 10. So this one will be 10 plus half into 15 minus 10 is 5. So 10 plus 2.5 will be 12.5. Now you can see that this 12.5 meter, this is obviously in meter. So this 12, because why it is meter? Because you are multiplying, in this case you are multiplying velocity with time, because 10 is velocity, so it is meter per second into 1 in second. So second will be cancelled, that is will meter. And on the second case also you are multiplying, this one is in second and this is change in velocity, that is meter per second. So second will be cancelled, so you are dimensionally correct. So meter per second, so it will be meter. So 12.5 meter. Now why it is 12.5? Because we can see that in between 2 and 1 second, in between 1 and 2 second actually, the particle is actually traveling a distance of 12.5 meter. Because we can see from the table of data that at 2 seconds the particle is 30 meter away from the origin, and between 1 and 2 seconds it is traveling 12.5 meter. So at 1 second the particle is situated, if you look at the displacement time graph of the particle, then you can find that at 1 second the particle is situated at 17.5 meter away from the origins. This is the location of the particle. This is the position of the particle. Position of particle at 1 second. 1 second. So and between 1 and 2 seconds the particle is traveling an extra 12.5 meter. So 12.5 meter, this is the distance traveled by the particle between 1 and 2 seconds. So if you add 17.5 plus 12.5, you will get a 30 meter. So at the end of 2 seconds, the particle is situated 30 meter away from the origin, and you can verify this from the graph. So again we can say that the velocity, the area of the velocity time graph, again we can say that area of velocity versus time graph is the distance covered by the particle in that interval of time. So this will be another property of uniformly accelerated motion. Now we will calculate what is the area of the acceleration versus time graph. So suppose again in between 1 and 2 seconds we need to find the area of this bonded portion. Now what is the area of this bonded portion? Length into breadth, height into breadth. So its height is 5 meter per second square and its breadth is 2 minus 1, that is 1 second. So if we multiply it, you can find that 5 meter per second square into 1 second. So you will get 5 meter per second. Now what is this? This is the rate at which velocity is changing. So the area of, here we are writing our 6th number point, that is area of acceleration time graph in uniformly accelerated motion is the change in velocity in that interval of time. So we can check it, because acceleration is velocity, change in velocity divided by change in time. So if we multiply with change in time, you will definitely get a change in velocity. So by using this equation, you can characterize an uniformly accelerated motion. So we have seen what is the advantage of using these graphs in the analysis of motion. So we have seen actually the graphical analysis of motion, and also we have studied different graphs of different parameters like velocity versus time graph, displacement versus time graph, acceleration versus time graph for these two kinds of motion. Although we yet to see the non-uniformly accelerated motion actually, and because in order to understand a non-uniformly accelerated motion, we need a special kind of mathematics, that is calculus, and we need to understand the concept of average velocity and instant velocity, and from that concept actually we will find how Newton and Leibniz has evolved a special kind of mathematics, that is the mathematics of small quantities, that is calculus. So we have seen these graphs. So on our next episode we will find that different cases of this velocity time graph, position time graph and acceleration time graph. Like we will find a retardation time graph, we will find increasing velocity time graph, decreasing velocity time graph, and that concept are very much useful. That concept will be needed for exam like joint and NEET, because you will find several times different cases of velocity time graph and position time graph in that kind of exam actually. So for that you need to find our next episode of graphical analysis of motion. Thank you for watching. This is Raja Banerjee from Finman Institute of Physics.